In the depths of the cosmic vastness lies a mystery that challenges everything we understand about the universe. Hidden among millions of stars is something colossal, a force so powerful that even light cannot escape. Perhaps the most powerful thing, scientifically speaking, ever discovered by humanity. Yes, I'm talking about black holes. The closest one to us is HR 6819, located just 1,011 light-years from Earth. But what is a black hole? Black holes are the most enigmatic regions of the universe, where the laws of physics as we currently know them do not apply. They are places where gravity reaches such extreme levels that not even light, with all its speed, can escape. The most common are stellar black holes. These bottomless pits swallow everything that approaches their so-called event horizon, which, while having a tremendous effect on the fate and circumstances of an object that crosses it, has no locally detectable features. But how do these phenomena arise? It all begins with a giant star that, after billions of years of nuclear fusion, simply runs out of fuel. Instead of exploding into a common supernova, it collapses in on itself, transforming its core into a point of infinite density, the singularity. This small but extremely dense region at the heart of the black hole contains an immense amount of mass that exerts such a strong gravitational force it warps space and time around it. To an observer from afar, the black hole is invisible, acting as a perfect black body since it reflects no light. What remains, however, is a force so powerful that anything that comes near it will inevitably be pulled in. What intrigues us is that despite their devastating power, black holes are natural results of the life and death of stars. They may have a dramatic origin, but their behavior follows the same gravitational laws that govern the planets in their orbits and the stars in their galaxies. In many ways, they represent both the pinnacle and the end of stellar life. Now, imagine an even more monstrous black hole. At a distance of 55 million light-years away lies a supermassive black hole with a mass 7 billion times greater than that of our Sun, the galaxy Messier 87. This cosmic colossus was the first to have its shadow captured in an image, in 2019, by the Event Horizon Telescope. Supermassive black holes are a class of black holes found primarily at the center of galaxies. Unlike stellar black holes, which originate from the evolution of massive stars, supermassive black holes were formed by immense clouds of gas or clusters of millions of stars that collapsed under their own gravity when the universe was much younger and denser. Supermassive black holes have a mass millions or even billions of times greater than the Sun. Most of the supermassive black holes catalogued so far are highly active, meaning they continue to draw matter into themselves, further increasing their mass. It is believed that supermassive black holes exist at the centers of nearly all galaxies. The black hole at the center of the Milky Way, named Sagittarius A*, has a mass approximately 4 million times that of the Sun, determined directly from the observation of stellar orbits. As you approach a black hole, there is an invisible and relentless boundary that defines the point of no return, the event horizon. This is the final limit. Anything that crosses this line, whether light, matter, or even yourself, is doomed to be sucked into the abyss with no possibility of escape. The gravity around it is so intense that even light, usually straight and swift, is bent and distorted, creating a bizarre spectacle of light and shadow. From the outside, an observer would see any object approaching the horizon appear to slow down, almost freeze in time, as the light stretches and fades. However, on the inside, the perspective is quite different. Once the event horizon is crossed, gravity becomes inescapable, and everything is pulled toward a place where the concept of space and time as we know it begins to fall apart. What lies on the other side? That is the question that continues to intrigue scientists today. Crossing the boundary of a black hole is just the beginning of the disintegration process. As you get closer to its center, you begin to feel the brutal effects of what scientists call spaghettification. The gravitational pull of a black hole doesn't act uniformly. The gravity is much stronger on the part of your body closest to the black hole than on the farthest part. No structure or form can withstand it. If you were an astronaut, you would appear to be stretched infinitely, your view of the universe distorting into a dizzying sequence of lights as time itself stretches. However, to an external observer, your fall would seem different. Time for those watching from afar would slow dramatically. To them, you would appear frozen in time near the event horizon, slowly being consumed by the black hole. Spaghettification is more than just a strange metaphor, it's the ultimate expression of the violence these colossal phenomena inflict on matter approaching them. A terrible fate, but also a breathtaking demonstration of the devastating power of black holes. Beyond distorting the space around them, black holes also alter the very nature of time. Near a black hole, time passes incredibly more slowly than anywhere else in the universe. This slowdown is the result of the extreme gravity surrounding them. The closer you get to the black hole, the more time stretches, like a ribbon being pulled to its limit. Although black holes are known for devouring everything around them, they also, in a sense, evaporate. This occurs through a fascinating phenomenon called Hawking radiation, predicted by physicist Stephen Hawking. Contrary to what one might imagine, black holes aren't entirely silent. Due to quantum effects that occur at the event horizon, tiny particles are created, and some of them manage to escape the black hole's gravitational pull. This seemingly impossible escape causes the black hole to slowly lose mass, as if it is gradually losing energy. This process, however, is not harmless. Despite its faintness, Hawking radiation carries an immense amount of energy. For any being or object approaching the event horizon, this radiation could be fatal. Though it isn't something that can be perceived from afar, the truth is that, over billions of years, this radiation would eventually cause the black hole to shrink and ultimately vanish completely. What happens inside the center of a black hole? That is a question that remains unanswered. It could be the end of everything or the beginning of something entirely new. Some theorists speculate that within a black hole, there could be other universes, or perhaps new dimensions. All we know is that once the event horizon is crossed, we're beyond the realm of conventional science. After all, there's no way to return alive, let alone intact, to tell the tale. If you want to follow this journey and discover what else the universe has in store for us, subscribe and be part of this exploration into the unknown. See you in the next video.